So in summary, we can say graphics is the selection of
mm,
points on a graph paper to draw the desired object. In this example, our object is a triangle. Now we move to the computer graphics or computer image. For computer graphics, is the selection of pixels or dots on a computer device, that is screen, to draw the desired image or object. Like graph paper, our computer screen, that is monitor, is also divided into rows and columns. Our computer screen or monitor is also, it is also divided into row and column, but its origin in laptop. So in computer graphics, the screen origin is at this place, and this axis is called y, and this is called x. So if we uh, draw the row and column, then intersection of row and column is called pixel in computer graphics. In computer graphics, this intersection is known as a pixel. This is known as a pixel, or it sometimes we can say it is dots. So in computer graphics is the selection of pixels and dots on a computer device. This is our computer device screen, that is screens, to draw the desired image or object. If we want to draw a triangle, if we want to draw a triangle, this is our object. Suppose it has point P1, P2, P3 like earlier. So we have to determine these points. These points must be determined on this screen. If we determine this point P1 on our screen, suppose P1 is at this place, and P2 is at this place, and P3 is somewhere like at this place. And if we combine this point, then we get the desired triangle, and this triangle is our object. So I have shown here, this is our computer screen in like a graph paper. So first we determine the point P1, then P2, and then P3. And after determining these three points, we combine the P1, P2, P1, P3, and P2, P3. Then we get the triangle. Similarly, we can draw the other object on our computer screen or device, or on computer, or on graph paper. So it is the concept of computer graphics or image on computer. Now there are some technical terms that will be used in our uh, topics. First is called aspect ratio. It is the ratio of horizontal lines and vertical lines. Suppose our screen is divided into different rows and columns. If there are, these are our rows and these are our columns, then we divide number of rows by number of columns. For this example, here 1 2 8, there are 8 vertical lines, and 1 2 3 4 5 5 horizontal rows. If we start from it 0, then it is equal to 6, and it is equal to 8. So there are 6 different rows and 6 different horizontal lines and 8 different vertical lines. So if we divide this 6 by 8, then we get the aspect ratio. Number of horizontal lines divided by number of vertical lines. For this example, total number of horizontal lines are 6 and total number of vertical lines are 8. So 6 by 8, that is 3 by 4, is the aspect ratio for this screen, and this value may be changeable. Uh, in our computer, we use different types of computer screen, and that screen has different number of rows and number of columns. So to find the aspect ratio of the screen, we first find the number of horizontal lines and number of vertical lines. If we divide this horizontal lines by vertical lines, we get the aspect ratio. And there is another term that is called resolution. Resolution, total number of pixels. For this example, there are 8 different vertical and 6 different sorry 5 different horizontal lines. So 8 into 6, number of pixels becomes 8 into 5, and it is equal to 40. So number of pixels on the screen is called resolution. Total number of pixels of the screen is called resolution, and high resolution gives the best quality. So if our computer screen is has a high resolution, I mean maximum number of pixels, then that screen will display the best uh, image or best object. So for best image quality, we need high resolution. Now we move to the main point, that is called transformation. In image processing, we need some image or some object, and how we can draw that object on our screen. For that, we need different types of transformation. So the definition of transformation is a way to calculate the new coordinates of the object due to changes in orientation, size, shape, etc. It is categorized into different form. So size means, suppose our rectangle is this one. This is our original rectangle. If we double the size, then the length will be double and width will be also double. So we get this rectangle. This is our original rectangle, A, B, C, D, and in this example, I have twice the length. If we twice this length, it becomes this one. So now the new coordinate of A is A dash and B is D dash, and the new coordinate of B becomes B dash, and the new coordinate of C becomes C dash. In this case, I have multiplied the length by 2 and width by 2. So if it is our 4 centimeter and it is our 2 centimeter, so 4 into 2, this is our 8 centimeter length, and 2 into 2, this is our 4th. So this type of changes is called scaling. In this example, I have scaled this object, this rectangular object, into new rectangular object, and the coordinate of A, B, C, D becomes different. So the coordinate of A, B, C, D changes. So this change or this new coordinate will be determined. What will be the coordinate of this? Suppose the coordinate of A is x1 y1, B is x2 y2, C is x3 y3, D is x4 y4. Then the coordinate of A dash becomes x1 dash to y1 dash, and the coordinate of B becomes x2 dash comma y2 dash. C dash becomes x3 dash and y3 dash, and this becomes x4 dash comma y4 dash. So what is the coordinate? How we will find this coordinate x1 y1, x1 dash y1 dash, x2 dash y2 dash? That concept is called transformation. To find the new coordinate of the original object, we need some transformation. So the definition of transformation is a way to calculate. Transformation is a way or method to calculate the new coordinate. Here x1 dash y1 dash is the new coordinate. So to calculate the new coordinates of the object, in this case the object is ABCD, and the size of this object becomes double. So due to double, the size of this length will be 4 into 2, that is 8. Due to this, the coordinate of this A, suppose it is our x1 y1, the coordinate of this x1 y1 now change. So to find the coordinate of this x1 dash y1 dash, we need some technique. That technique is called transformation, and this type of technique is called size changes, and this is the technical term of this size change is called scaling. That is written here. Scaling is used to change the size of the object. And if we want to rotate this ABCD, this ABCD is rotated like this in 45-degree angle. If we rotate this object in a 45-degree clockwise, then the ABCD becomes this one. And due to rotation, the coordinate of this object will be again changed. So we have to find the new coordinate of this rotated rectangle, and this coordinate will be found by the help of rotation. So rotation is a method to find the new coordinate of the object if that object is rotated by some angle. You can rotate this object by an angle 45-degree or 60-degree or 30-degree or 180-degree up to 360-degree. So we can rotate this object from 0-degree to 360-degree. We can rotate this object from 0 degree to 360-degree. So this type of changes, or due to this rotation, the change of coordinate will be calculated with the help of rotation. Sometimes we want to move this object. Sometimes we want to move this object from this location to this location. If we move that object from one location to another location, then the coordinate of that object again changes, and to find the new coordinate of this ABCD, we will use translation. So there are three different ways to find the coordinate of the object, and that are translation, rotation, and scaling. So this type of transformation is known as a basic transformation. In basic transformation, we will learn three different techniques that is called translation. In case of translation, the object will be shipped to the another location. It is our original location of the object P or object of or object A, and now this object is moved at this place. So the coordinate of this object will be changed, and this type of movement is called translation. But if we rotate the object in some angle, then it is called rotation. And if the size is changed, or we can increase the size of object, or we can reduce the size of object. If we want to expand or reduce the size of object, we need scaling. So translation is a method to find the new coordinate when object is moved from one place to another place. And rotation is a transformation method to find the new coordinate of the object when we rotate the object by an angle. And scaling is a method to find the new coordinate of the object if we expand the object or we reduce the object. So these are the three basic transformations. There are other transformation also, that is called shearing and reflection. We will discuss later. So there are five different transformation. First is called translation, second is rotation, third is scaling, and other is called shearing or reflection. So all these transformation we will learn one by one, and these transformations will be used in our image processing for calculating the coordinates. So translation, the notation to show the translation. To show the translation, we use the notation T. And suppose our graph paper or our screen is divided into four coordinates, then we know if it is our x, then it will be our x dash, and if it is our y, then it is y dash. And we know the value in right hand side of the x will be positive, so it is 1, 2, 3, 4, and 5, like this. And the coordinate of x dash in left hand side will be negative, so it is our -1, -2, -3. Similarly, the coordinate of y in upper place, it is 1, 2, 3, like this. But in bottom place, it is -1, -2, -3. And if our object is at this place, then it is in a positive direction. But if we move this object, this is our object, and this object is in positive coordinate. But if we move this object at this place, then the uh, value of this translation will be negative, so it is in our negative place. So the positive translation is known as a t plus b, or negative translation is shown by t minus b. Actually the translation notation is t, but in positive direction it is t plus b, or simply we can write tb, and in negative direction we will use minus b. This is there are two different notation, t minus b or t plus b. Similarly, if we rotate the object, then suppose it is our object, then this object can be rotated in a clockwise direction, or it can be also rotated in a anti-clockwise. If we rotate it in clockwise, then it is called negative, or If it is rotated in a anti-clockwise, then it is called positive rotation. So to denote the rotation, we will use symbol R, and to denote the negative rotation, we will use R theta minus, and for positive, we will use R theta plus. This type of notation will be used in our translation. Now, for scaling, since scaling, we know there are different types of plane. uh, in coordinate system, there are 2D coordinate system and 3D coordinate system, 4D coordinate system. In 2D coordinate system, there are two principal axes, x and y. So we scale scale the object either in x or in y, or in x and y both. In the previous example, I have scaled the object in x and y both. But if we scale this object, if we resize this object in a x direction only, suppose it is our 2, and it is our the length of width of this object is 2, and we want to increase the size in length only, not in width. If we double its length, then this object will be look like this. The length becomes 8, the length becomes 8, but the width remain 2. Width will be 2, but the length will be double. So in the this type of scaling is called SX, because I have scaled this object in length only, one axis. So this is called Sx. And if we double the size of width, then this object will look like this. The width becomes 4 and length is same. So in this case, the width is changed, so y value is increased. This type of scaling is called Sy. And in previous example, I have double the length as well as double the width, so that scaling is called Sxy. So there are three notation in 2D. First is called Sx in x direction, Sy in y direction, and Sxy in both direction. In 3D, there are three different axes: x axis, y axis, and z axis. So we can scale the object in x axis, y axis, in z axis, or in xy plane, xz plane, or yz plane. So in 3D, there are different types of scaling symbols. In 3D, we can scale our object in x direction, y direction, z, xy plane, yz plane, xz plane, and sxyz. I mean in all directions. So we will learn all transformation in 2D as well as in 3D. 2D and in 3D. In 2D, there will be two dimension, x and y, but in 3D, we will use x, y, and z. As we know, the direction of x, the direction of x is denoted by I vector, and the direction of y is denoted by j vector. J vector, and the direction of z is denoted by k vector. So three vectors are used to denote the direction of x, y, and z. In x direction, we will use vector I; in y direction, vector z; and in z direction, vector k. and this arrow denotes that this is our a vector, not a magnitude. It is our vector. And you know, all unit are divided into all units are divided into two categories, scalar and vector. In scalar case there is no direction, while in case of vector there are magnitude as well as direction. So in a vector uh, form we need direction. If we denote the point A or B, suppose it is our A and it is our B. If we join this A and B, then we get a segment AB. But this AB has magnitude. Suppose it is of a 4 unit length. So it has magnitude, not direction. So to give the direction, this AB is simply a scalar method. But if we put direction at this place, now this AB has initial point A and end point B, initial point A, end point B, and the magnitude is 4. And now this AB will be represented like A arrow. So this AB becomes a vector. But in case of simple AB, it is our scalar, and this AB denotes the magnitude of this segment. But this AB arrow denotes the magnitude is 4. To denote the magnitude, we write this vector. We write this vector in a modulo. This modulo represent the magnitude, and this notation represent the direction from A to B. And this segment has two different directions. If A is initial, then that direction is AB. But if the initial point is B and end point is A, then the direction will be BA, and this vector will be denoted by B to A. First First point denotes the initial and second point denotes the end point. So this is also our a vector. So any segment has two different vector AB and BA like that. Similarly, each direction has a vector, and that vector on X is known as a I, on Y it is J, and on Z it is K. We will use all these concepts in our transformation. Now we come to the other type of transformation, that is called sharing. Sharing, if we want to change the shape, if we want to change the shape of object, suppose you want to convert a potato into an apple, or a tree into a lion. This type of changing or changing of shape for the object is called shearing. So to change the shape of the object, we will use shearing transformation. In shearing, there are different notation. For 2D notation, we will use SHX. It means shearing in X direction. SHY means shearing in Y direction, and SHXY means shearing in X and Y both. Suppose it is our X axis and this is our Y axis, and there is a rectangle like this. And if we apply a force on this place, then this rectangle is shifted into this this rectangle shifted like this. So if this type of changes, this is our ABCD original figure, ABCD, and now the new figure becomes a dash, a dash, d dash, b dash, and c dash. So this type of changes or change in shape of the object will be calculated by the help of shearing. And if we use only two dimension x and y, then there are three different types of shearing symbol: SHX, SHY, SHXY. And for 3D, we use three direction. So there are a number of shearing. SHX means X, shearing in X direction; SHY, shearing in Y; SHZ, shearing in Z; and SHXY means shearing in XY; SHYZ means shearing in YZ; and SHXZ means sharing in XZ; and SHXYZ means sharing in all directions. So these are the notation of sharing. Then other type of transformation is called reflection. Suppose there is a mirror. Suppose there is a mirror. It is our mirror, and we place an object at this place. If we place an object at this place, then what will be the image of this object? This object will be represented behind this mirror. And suppose the coordinate of this object at this place is x comma y. The coordinate of this object at this place is x comma y. Now if we take the mirror or reflection of this object on this mirror, this is our mirror. So the distance of this object, suppose this is our p and coordinate is xy, then the new coordinate becomes p dash, and the new coordinate of x becomes x dash comma y dash. So how we will calculate this coordinate, new coordinate? To calculate this new coordinate, we use reflection method. And at this place, suppose the value of x is 2 and the value of y is 4, then you guess the coordinate of p dash. What will be the coordinate of p dash? X will remain same, so x dash will be 2, but the y dash becomes negative, because you know the upper side of this y axis is positive, and in bottom or bottom place the value of this y becomes negative. So only the value of y becomes negative, so and the size will remain same. So the coordinate of this x dash y dash by observation is 2 and minus 4. The coordinate of this object at this place is 2 4. Suppose then the coordinate of this p dash becomes 2 comma minus 4 as per our observation. But how computer can find this coordinate? To find the coordinate of this new object, using a computer, or in computer we use a transformation that is called reflection. And this reflection has also different notation in 2D and 3D. If we place the mirror in x direction, then this mirror is called mx. And if we put the mirror on y axis like this, then it is called my. And if the mirror is placed at an some angle, suppose it is our mirror is placed like this, then what will be the new coordinate of this object on this new mirror? Will be represented like this. In this case we need mirroring in x and y both. So if a mirror is inclined, if mirror is inclined, then that reflection or mirroring is called mxy. And if it is along the x axis, it is mx. And if mirror is along y axis, then it is my in 2D. But in 3D, there are different notation. If mirror is only in x direction, mx; if it is in y direction, my; if it is in z direction, mz; if it is in xy plane, then it is mxy; and if it is yz plane, then myz and xz; and if it is inclined to all plane, then it is called mxyz. So till now we have discussed the different types of transformation and their notation that will be used in our image processing method. So first we will see or learn what is translation and how we can calculate the coordinate of object after translation. So transformation in computer graphics or in image processing. In image processing, the classification of transformation is categorized into three categories. First is called Euclidean. Euclidean. Second is called um, affine transformation, and third is called projective. Projective method. In Euclidean, the transformation is translation and rotation. Translation and rotation are the part of Euclidean. Translation and rotation. In affine, the scaling and sharing. Scaling and sharing. These two transformations are the part of affine. In projection, there are different type of method that is called perspective projection, perspective projection, orthogonal projections, etc. So to know the perspective and orthogonal method, we will learn about the projection. So this is our next topic. But today we will discuss only Euclidean transformation method, that is called translation, rotation, scaling, and sharing. But there is one more transformation that is called reflection, and it is known as a other transformation. So in image processing, there are four categories. First is called Euclidean transformation, second is affine transformation, third is projective transformation, and fourth one is other transformation. In other transformation, we will learn about the in other transformation we will learn about the reflection. So the basic concept is translation, rotation, scaling, sharing, and scaling. Projective is another type of method that will be discussed later. What is perspective projection and what is other orthogonal projections, etc. And all these topics are the part of your paper block 3. All these are the part of block 3. In block 3, we will study about the transformation, projection, and in block 4 we will learn the tools about the about the image processing, like machine learning, Python, concept technology, etc. But in block 1 and block 2, we will learn about the image processing. To understand this image processing concept, we have the concept of all transformations, and that is discussed in our block 3. That's why I have started from this block 3. After discussing all these transformation, then we will move to the or switch over to the block 1 and block 2, where we will study about the image processing. Now we will discuss in details about translation, rotation, etc. What is translation? There are two different type of translation. First is called in 2D and second one is called in 3D. So there are in there are uh, is my screen visible? Okay,
Yes, sir.
okay. So in translation we will discuss 2D translation, then 3D translation. In 2D translation, there will be two different notation that I have discussed earlier, t minus v and t plus v. If our translation or movement in is in positive direction, then it is t plus v, and if it is the reverse of positive, then it is called t minus v. So t plus v is also simply we can write tb. This tb denotes the t plus v. In some book you can see also tv plus. So there are different notation to represent the positive translation. These three different notations are used for positive direction. For negative direction you can use t minus v or tv minus. So it depends upon the writer concept, but the concept are both concept are same. You can either use this notation or this notation, both are equal. In translation, translation is a process to change the position of an object. This object may be rectangle, square, circle, ellipse. These are the geometrical figure or geometrical object. But in real life we can use different types of object also, like tree, mobile, etc. For simplicity we will always use a, an object. That object is point. For simplicity we will, because point is also an object, so for simplicity this point will be discussed in all type of translation or transformation. Point, the coordinate of this point will be at least x and y. There are two different coordinates of any point, either x or y. For simplicity I will use a single point, but if you use a rectangle, if you use a rectangle, there are a number of points. Suppose, sorry, suppose our rectangle width is 2 and length is 3. So there are 3 columns and 2 rows. This this is a point. This is a point. If we find the coordinate of this point, then we can also find the coordinate of this point also. We will move to the y direction above, one cell above, and in right side if we move from this place, suppose the coordinate of this place is 2 comma 3, then the coordinate of this point will be 2 comma 4. If our origin is in bottom, then this is our 2, then it will be 3. So the coordinate of this place will be 2 comma 4. And what will be the coordinate of this place? The coordinate of this will be, the value of x will be increased by 1. So 2 becomes 3 comma 3. Row becomes same. This is our 3, this is our 4, this one is our 2, 3 and 4. So the coordinate of this cell will be, x value 4 and y value 3. So we can calculate the coordinate of all other points. If we can calculate the coordinate of single point, then we can also calculate the coordinate of other points by using the same rule. So object is the point is the smallest object, and that's why we use this point as an object. So translation is a process to change the position of an object along a straight line path from one coordinate location to another. This is our first coordinate location, this is our another coordinate location. So at this place the coordinate of this point is xy, but at this place or at this new location the coordinate of this point p becomes p dash, and the coordinate of xy becomes x dash and y dash. We translate a two-dimensional point by adding translation distances. How long we move this point p to p dash. So if the coordinate of this p is xy, it means, if the coordinate of this p is xy, it means the length of this place, the length of this place, sorry, the length of this place is x, and the length of this place is y. This place is y. So this is our x and this is our y. So the coordinate of this point p, this point p is xy. And if we shift this point, or if we translate this point at this p dash, then we add tx. This is our extension. So I have added tx unit in x direction. So the new coordinate of this x dash becomes x plus tx. I think you can understand this. This is our x, and we have extended this x to up to tx. So the length of this place is tx. So what will be the coordinate at this place? What will be the coordinate of x at this place? So at this place the coordinate becomes x plus tx. So this x dash becomes x plus tx. And in y direction we extend the y up to ty. So this is our ty, and this ty, y plus ty becomes the new coordinate of this y dash. So y dash becomes y plus ty. I think it is clear to you. So the coordinate of x dash, new coordinate of this x dash becomes x plus tx, and y dash becomes y plus ty. And it is mm, mentioned in this figure, and you can also understand all these things. Now let an object point, this is our object point p xy, and the vector or this coordinate of this is xi plus yj. Xi means I indicates the direction in x axis, and yj, j indicates the direction in z axis, because it is not necessary that x will be horizontal. It may be like this, x and y. In this case the x becomes this, and suppose this is our point p, then this is p at this place, and if we shift this p dash, then this is our tx, and this becomes like this. So the same concept is used here. It is our p and it is our p dash, but the direction of this frame is different than the direction of this frame. This is our another frame in another direction. So to indicate the direction, we will use the direction of x and y both. That's why I have written here the coordinate of x and y becomes xi and yj. We move to p dash, x dash y dash by the given translation vector, and this translation vector that I have denoted by capital T, and this vector location is tx comma I and ty comma j. This tx in the direction I, and since x is in our I direction, so tx will be also in I direction, and y is in our j direction, so the ty will be also in j direction. So the translation vector or movement distance becomes v equal to txi plus tyj, where tx and ty are the translation factor in the x and y direction respectively. Now we can formulate all these things in a in mathematical form, and in mathematical term we can say the p dash is the new coordinate, or p dash is the new object after transformation, and p is the old coordinates plus v is the translation vector. So if we denote this p dash as a, because p dash has two different coordinate x and y, and the coordinate of x and y is x dash and y dash, and we have to determine this x dash and y dash. In earlier figure, x dash is nothing but the x plus tx, and y dash is nothing but the y plus ty. So the coordinate of p dash is, the coordinate of p dash becomes x dash y dash, and the coordinate of this new coordinate is equal to the coordinate of old coordinate. Old coordinate is x and y, and we add the translation vector, and this translation vector is nothing but the tx and ty. So if we add this tx with x, this x and tx are combined, then we get x dash, and this y and ty is combined, then we get y dash, y plus ty, that is y dash. So by this way we can calculate the new coordinate of the object after translation. It is the concept for single point. But if we want to move a rectangle, that is the combination of multiple coordinates, for that we will convert all these mathematical concepts into matrix form. For calculation, this concept will be used for single point, but if there are infinite points, or a number of points are given, then how can you calculate the coordinate of each point? Because if you shift this object abcd that has different values like this, so this will be shifted at this place. So you have to calculate the all coordinates, this point to this point, this point to this point, so again this one to this, and like this. So you have to calculate 6 times. It is a simple object, but in real life the object has finite or many different coordinates. So to find the coordinate of all those coordinates, we will convert this formula into a matrix form, and this matrix form will help us to calculate the multiple points coordinates. Yeah. Okay. Okay. Let me check it. Okay. Uh, the X is, suppose this is our graph paper. On a graph paper, we use two dimension. If you use two dimension, then there will be two axes. First is called X and second is called Y, as you know. And it is divided into zero. This is the intersection of X and Y is the origin. And you can take any unit for to represent the value 1. Suppose it is our 0, then it is our 1 unit, then it is 2, then it is 3, like this. And similarly on y axis it is 1, 2 and 3 in positive direction. But if you move in bottom place, then the value of y becomes -1. As you know, it is I think it is clear to you. uh, on graph paper, the upper
Yes,
part
sir.
is positive and the lower part is negative.
Yes, sir.
Similarly, on graph, the right hand side is positive and the left hand side is negative. I think you know.
Yes, sir.
Okay. So if you represent, if you draw the horizontal line along this y coordinate and vertical line along this x coordinate, then these horizontal and vertical lines intersect the row and column, and this intersection is called the cell. And this cell is represented by unit, this one and this one. I mean, the 1 1, this cell is represented by 1 1, that is the value of x is 1 and the value of y is 1. But if you use this place, so at this place, it is 1 2 3. This is the axis. Axis value is, x value is 3 and y value is 1 2 3 4. So this is the way to find the value of x and y. And this coordinate is known as a point. This coordinate is known as a point. So there are different points. This point, this one is also a point. So there are different, each cell is known as a some point, and the coordinate of that point is represented by this notation. I think now it is clear to the meaning what is the value of x and y.
Yes, sir.
Okay. So calculation of that coordinate will be simpler if we convert, if we convert these mathematical formula into a matrix form, then we can calculate the coordinate of multiple points in a short time. So how we will convert all these mathematical terms into a matrix form? For that, we will use this concept. The translation distance point px and py is called translation vector, or it is sometimes also known as shift vector. So equation 1 can be above equation 1, that is p dash, and p dash is nothing but x dash y dash. And is this p dash, in equation I have shown you, p dash is equal to p plus b in equation 1 in previous page. P dash is p plus b and p dash is nothing but the x dash y dash. Similarly, p is nothing but the coordinate of original object, that is xy, and v is nothing but tx and ty. So if we combine all these things, then the coordinate of x dash becomes x plus tx, and the coordinate of y dash becomes y plus ty, that I have discussed in earlier figure. To convert the above addition of matrices, here I have added two different values. This is the coordinate of original or mm, location at original place, and this is our distance by which we have extend the point or move the object. So we add all these things, but we can combine all these things into a matrix form or in a multiplication form. To convert the above addition of matrices into a multiplication matrices, in this place we have used I have used the addition matrices, but we can also apply the multiplication matrices on this object. We use a row matrix instead of column matrix. This is our column matrix. So if we use row matrix, then p dash becomes p dash equal to p dot tv, where p dash is the location of new place of the object, and this is the location of the original, and this is our translation vector, and tv is nothing but this one, p is nothing but this xy, and p dash is equal to this one. So this equation, if we simplify this equation, this tv is x dash equal to x plus tx, and y dash is equal to y plus dy. So this x indicates, if we write x, it means there is a coefficient before x, and if there is a coefficient 0, then it becomes 0. So if we multiply, if we write somewhere x, it means there is a coefficient 1, and if we write 0, it means there is no any other value. So this x plus tx, this x plus tx can be written in terms of this x, that is 1 dot x, but there is no y, it means the coefficient of y is 0 and plus tx. So this equation is rewritten in this form: x has one coefficient, y has zero coefficient, and tx has one coefficient, but I have hide that coefficient. So this is written in this form, and this y can be written in this equation. The term x is 0, the coefficient of x is 0, but the coefficient of y is 1 and dy. So this expression is rewritten in this form, and this expression is rewritten in this form, and with the help of this new form, with the help of this new form, you can create a matrix, this one. So tv, this is the value of tv. So tv is equal to 1, this 1 is written here, this 0 0, and y dash, this 0 0, sorry, uh, sorry, this 1 is written here 1, this 0 is written here, and this tx is written there. Similarly, y dash can be written like 0 0 1 and ty, and we add one more column, we add one more column for simplicity in calculation of in calculation. To simplify the matrix form, we add one extra column, that is called homogeneous column. This extra column is called homogeneous column. So in 2D, we add one more column, that is called homogeneous column, and denoted by capital H. After adding this homogeneous coordinate, we can say this notation is in HCS form. This notation is in HCS form, homogeneous coordinate system. Without this extra column, it is in coordinate system. In coordinate system, we use in coordinate system we use only two dimension in coordinate system. But in case of HCS, homogeneous coordinate system, we add one more column or one more dimension. That is called homogeneous, and it is denoted by HCS. So, and this homogeneous coordinate system is introduced to make the calculation simpler. So to make the calculation simpler, we add one more column, that is called homogeneous column, and the value of this homogeneous column may be 0 or positive or negative, like this. So in 2D dimension, in 2D dimension, the coordinate of P, the coordinate of P is x and y, x and y. It is a coordinate system. This representation is called as coordinate system and or Euclidean method. But if we add one more column x y comma h, then this this representation is known as a HCS, homogeneous coordinate system. This is Cartesian coordinate system. This is in the form of Cartesian coordinate system, and this is in the form of homogeneous coordinate system. In Cartesian coordinate system, finding the coordinate of new object is difficult. But with the help of this homogeneous coordinate system, we can calculate the new coordinate of object in an easy form. That's why we introduce a new coordinate system, that is called homogeneous coordinate system. And we will see how it is easy. So new coordinate system becomes P dash equal to P dot TB in multiplication form, and it is in Euclidean system. And I have just discussed in Euclidean system, the xy is x plus dx. New, the coordinate of new object is x plus dx, y plus dy. But in case of homogeneous coordinate system, we introduce one more column. Then this xy becomes xy1 in homogeneous, and this x plus tx and y plus ty becomes x plus tx, y plus ty comma 1. Without this h third coordinate, it is Cartesian, and with the help with the h value, it is in homogeneous. So to denote the homogeneous, P dash equal to P dot TB in multiplication form, it is in Cartesian coordinate system. But if we convert this system in HCS form, we will write it P dash H PH dot TB, where H denotes the homogeneous coordinate system. And in homogeneous coordinate system, the coordinate of P dash H becomes x dash y dash 1. This is the h value, and in homogeneous pH it becomes x, y and 1. The value of homogeneous form of TB that I have discussed here, TB is this one, and this is obtained from this. So if we multiply each coordinate by this translation vector, this is called translation vector. If we multiply each coordinate by this translation vector, we get the coordinate of new object. So in the Cartesian form, the P dash H will be written like this, and PH written in this form, and PV in this form. it is in a row matrix, but we can also use it in column matrix also. In column matrix, it can be written like this: x dash y dash 1, x y 1, and 1 0 t x. So this value is uh, this column is converted into row, and this column is converted into in this row, and this third column is converted into third row. So it becomes in the column form. So p dash h is x dash y dash 1, ph is equal to x y 1, and tb in row form it is this one, and in column form it is this one. Some author use this row matrix to calculate the new coordinate, and someone use this one. So both representation are same, but it is in a row matrix, and it is in column matrix. This is the concept of 2D, but in case of 3D, we will introduce we will introduce one row and one column extra in 3D, and we will discuss it later. Before going to discuss the 3D, we take some uh, example how we will calculate the coordinate of any object by using this translation. Suppose it is our object. This object is a uh, this object is a square, because the length and breadth both are 5 unit. This is our length, this is our breadth, and the coordinate of this a is 0 0, and the coordinate of b is 5 comma 0. It means this is our xa, and this is our ya. You can also write x1 y1. This is our xb and yb. The coordinate of yb is 0, and the coordinate of xb is 5. Similarly, this is our c, xc, and yc. Similarly, you can write the coordinate this. You can also write x1 y1, x2 y2, x3 y3, x4 y4. The coordinate of this is given here. Translate a square ABCD. This ABCD is a square with the coordinate a0. A0 0, x is 0, y is 0. B x5, y0. C x5, y5, and D x0, y5. So this is our original object. This object is our original object, and it is a square. This object is a square, and this square object is move in x direction by 2 units in x direction and 3 units in y direction. It means this a is shifted to 2 unit in x direction. Suppose it is our 0, then 2 units. Suppose it is our 2 unit, and 3 unit in y direction. So a this a is shifted 2 unit along the x axis and 3 units along the y axis. So this a is shifted somewhere at this place. This a this a is shifted somewhere at this place. So if a is shifted here by using this x in 3 direction, and sorry, x in 2 units and y in 3 units, then this a becomes x direction. In x direction it becomes 2, and in y direction it becomes 3. Similarly, what will be the coordinate of this b? So we have to add 2 in this value 5. So the value of 5 becomes 7, and in y direction we have to add 3 units, so it becomes 3. Similarly, what will be the coordinate of this c? So this is our a dash, this is b dash, this is c dash, and we add 2 in x direction and 3 in y direction, so it becomes 7 comma 8. And what will be the coordinate of this d? New coordinate of this d, the new coordinate of this d, that is d dash, equal to add 2 in x and 3 in y, so 0 plus 2 2 and 5 plus 3 8. So we get the new coordinate of a dash. If we add 2 and 3 in 0 0, we get 2 3, and if we add 2 and 3 in 5 0, we get 7 3. So we calculate the points a dash, B dash, C dash, D dash by manual. We manually add all these things. We can calculate the new coordinate of this shifted ABCD or translated ABCD. But if the number of coordinate is in 1 lakhs, million, in trillion, then it is not possible manually. Manually, it is not possible. So we need some formula to calculate all these million points. So how we will use that above formula to calculate all these coordinates? Uh, you must remember all these things. Now we will find the coordinate of all these a dash, b dash, c dash, d dash by using the above formula. Here tx is 2 by the question. From the question, 2 unit in x direction, that is tx, tx equal to 2, and 3 units in y direction, that is we uh, use ty
One.
equal to 3. It is given in our question. So the value of tx equal to 2 and the value of ty equal to 3. So the new coordinate of ph, and what will be the new coordinate of p dash h? But the old coordinate of a is 0 0, that is given here in question. B is 5 0, c is 5 5, and d is 0 5, and we make it in homogeneous. So each point add one extra dimension, that is 1, to represent the coordinate of point, to represent the coordinate of point, to represent the coordinate of point, we introduce one new value 1, that is the value of h equal to 1. So this 0 0 becomes 0 0 1. Yeah, yeah. Okay, okay. uh, in case of Cartesian coordinate system, there are different Cartesian system to represent the Cartesian coordinate system and polar coordinate system. There are a number of coordinate systems to represent the value of coordinate. In Cartesian coordinate system for 2D, in Cartesian coordinate system for 2D, we use two dimensions, x and y. X represent the value of x coordinate and y represent the value of y coordinate. But in case of polar coordinate system, we use r and theta to represent the coordinate of point. But these two things are used in coordinate geometry. In coordinate geometry, we use this concept. In case of computer, we need to calculate the coordinate of xy in a multiple for multiple points. To calculate the coordinate of multiple points, this Cartesian coordinate system is not sufficient for mathematical ground. That's why we introduce a new coordinate in 2D, that is called h, and this h is the form of homogeneous. The value of h becomes the value of h is either positive or negative. But if we take the value of h equal to 1, then the point will be represented in x, y, comma 1 in homogeneous system, in HCS. But in case of Cartesian coordinate system, we only use x and y, not h. So this is the homogeneous coordinate system for 2D, and the homogeneous coordinate system for 2D becomes xy1. So any point that has the value xy, you have to add 1. That's why I have added here 0 0 to 0 0 1. I think it is clear. The coordinate of A is 0 0 in Cartesian coordinate system, you know. But if you represent it in a homogeneous coordinate system, you have to add one extra coordinate, that is called h, and the value of h is 1. So 0 0 1. For all points, you have to add one extra. That is for h value. I think it is clear.
Yes, sir.
Okay, so this one, this 0 0 becomes 0 0 1, 50 becomes 501, that is the value of b, and this 5 c is 551 and d is 0 5 1. But this is augmented matrix. This value represent HCS form of A. This is HCS form of B, HCS form of C, HCS form of D. If we remove this point A, B, C, D, so pH becomes 0 0 1 by 501, 551, 0 5 1. This augmented matrix is separated in two different matrices. First is coordinate and name of point, and second is the coordinate of that point. This is the these two matrices are combined in this pH. So this is called augmented matrix. We remove this ABCD because we know the first value is for A, second value for B, third is for C, and fourth for D, for calculation purpose, so that we can simply calculate the numeric value. So this becomes pH value. I think now it is clear what is pH. pH represents the coordinate of all points that are used in that object. In this object, there are 4 points. So I have used 4 points. And manually, we have calculated the new coordinate of A dash, B dash, C dash, D dash. But it is easy for few points. If there are a number of points, then we need a matrix form. This is our matrix form, and this is the value of all A, B, C, D, and Tx and Ty is given in question. Now, how we will calculate the value of pH? Tv is the formula of Tb is 1 0 tx 0 1 tx in a homogeneous coordinate system, 1 0 tx 0 1 ty 0 0 1, and tx is 2 and ty is 3. So we put the value of tx and ty, so we get 1 0 2 0 1 3 and 0 0 1. And p dash h, p dash h is nothing but the a dash, b dash, c dash, d dash, because it is the coordinate of new object at a new location. So what will be the coordinate of A dash? To find the coordinate of A dash, B dash, C dash, D dash, we multiply the coordinate of original object with the translation vector. This is our coordinate of the original object in homogeneous. So pH is 0 0 1 that I have shown. This is our pH value. So we put this pH at this place, and the Tv value, this is our Tv translation vector, and Tx is 2 and Ty is 3. So if we put Tx equal to 2 and Ty equal to 3, we get this one. So this value is multiplied by this. Now we can multiply. How we will multiply two matrices? This row will be multiplied by this column. So if we multiply this 0 with 1, 0 into 1 plus this 0 into this 0, 0 into 0 plus 1 into 2. So 1 into 2. So if we simplify this, 0 into 1 0 plus 0 into 0 0, that is 0 plus 0 plus 2. Now it becomes 2. So it is 2. Similarly, if we multiply this row with this column, 0 into 0 0, 0 into 1 0, 1 into 3 3. So 0 into 0 plus 0 into 1 plus 1 into 3. After simplification we get 3 only, because this becomes 0. So this 3 is written here. Now this 0 0 1 is multiplied by this 0 0. So 0 into 0 0, 0 into 0 0, and 1 into 1 1, that is 0 into 0 plus 0 into 0 plus 1 into 1, and after simplification we get 1. So 2 3 1. So this is the first value. If we multiply this second row with these three columns, we get 7 3 1. Then we multiply this third row with this three column, we get 7 8 1. You can calculate it. And if we multiply this value with all these three, then we add, then we get 2 8 1. So this calculated value, this calculated value is the coordinate of new object. And if we, this is in HCS form, this is in HCS form, and if we convert it into Cartesian coordinate system, CS, so we have to remove this extra column. If we remove this, then we get 2 comma 3, 7 comma 3, 7 comma 8, and last is 2 comma 8. And you know, this is for A dash, this is the coordinate of B dash, this is the coordinate of C dash, and this is the coordinate of D dash. You can compare this value with the manual calculation. The value of A is 2 3, you can see. Yeah, the value of A is 2 3, the value of B dash is 7 3, you can see. 1 minute. This is our calculated value, and this is our, this value is obtained with the help of formula. Okay, manually I have calculated the value of A dash is equal to 2 3. You can see here, by this mathematical formula we get the value of A. The value of A is 2 3, that is equal to this. Value of B dash is 7 3, value of C is 7 8, and the value of D is 3 8. So by using this formula we can calculate multiple points in a second, by using some mathematical tools like Python, C, or any other language. So this is the beauty, or this is the benefit of this homogeneous coordinate system. So this calculation makes very simple concept to calculate the coordinate of new object if the number of points are multiple. uh, Manually you can calculate for 2, 3, 4, 5, or 10, maximum 50 different points, but with this help of mathematical formula we can calculate million trillion coordinates in a second or in a few minutes. So this is the concept of homogeneous coordinate system. I think now it is clear to you why we use this formula.
Hello, sir. Please, where I'm
Yeah,
not too clear is the transformation matrix, the TV.
yeah. Have you any problem?
I'm not too clear with the transformation matrix.
Okay.
Can
uh,
you? Yes.
if you see two or three more example, it will be clear to you. So give me some time. I think it will be clear to everyone. So after calculation, you see this is the coordinate of a dash. So this a coordinate of a is 0 0 initially. This is the coordinate of original object, and this is the coordinate of new object. The coordinate of this new object a becomes a dash, that is 2 3. This is our 2 3. So the coordinate of b is 7 3, coordinate of c dash is 7 8, and coordinate of d is 2 8. So this is the translated object after translation. Now we come to the 3D. So in 3D we will use three direction, and that direction is x, y, z. So each point will be represented with the help of three coordinates x, y, and z. As you know, in three dimension there are three coordinates in Cartesian system. In Cartesian system there are three different coordinates x, y, and z, and the direction of x is I, and the direction of y is j, and the direction of z is k. I, j, k are the vectors direction for x, y, and z. So you can place arrow above this I, but for to make it simple, I have hidden this arrow. But you know, I, j, k are the direction. I for x direction, j for y direction, and z for k direction. For 2D, v is equal to txi plus tytyj for 2D. But in case of 3D, we introduce a new term tzk, and coordinate becomes x dash, y dash, z dash. So this is the concept. Now how we will calculate this? Suppose there is a point P in 3D. So the coordinate of this P is a xyz. Suppose this is our point and this point is our object. Since it is a point, so there are only one coordinate for this P, and that coordinate is xyz. If we move or translate this P to P dash, then this xyz becomes x dash y dash z dash. Now, how we will calculate the coordinate of this x dash? While uh, when we know the coordinate of x, y, and z. So the coordinate of x, y, z are given, but we have to calculate the coordinate of x dash, y dash, z dash. For that, we will use the above concept that I have used in 2D. For 3D, for 3D, we will use this formula. A point x, y, z will be denoted like this: x plus tx plus ty z plus z plus dz. Thus, the new coordinate can be written like this: tv in 2 dimension, the tv is equal to this much only. This is the value of 2D. But when we use 3D, one new row is introduced, and that row for z direction. So z dash becomes z plus tz. And if we expand this x tx in xyz, the coefficient of x becomes 1 and the coefficient of y and z is 0 here, and tx. But in this second row, the coordinate coefficient of x and z, are 0, but the coefficient of y is 1. And in case of third equation, the coefficient of x and y are 0, but the coefficient of z is 1. So this equation or these equation is rewritten in this form, in which all directions are shown. Uh, in this direction, only x, y, and z are shown, but in this case, I have shown the value of x, y, z. But the coefficient of y and z for first is 0, and if we multiply this 0 with y, we get 0. This is also 0. So in simple form, 1 into x equal to x. So simply we can write x plus tx. So x plus tx is expanded in this form. And I have also discussed this concept in 2D. Similarly, this second one is also converted into in this form, and third one is converted into in this form.
Hello, we can't hear you, sir.
Okay, now I think time is over. So okay, so if we convert this into matrix form, the TV becomes 100 tx, 100 tx, 010 ty, 010 ty, 001, and tz. And this new coordinate is introduced due to homogeneous coordinate system. Uh, I have discussed this homogeneous coordinate system in uh, 2D also. So this is the um, translation vector for 3D. And if you have the coordinate of any object P h, then you can calculate the coordinate of P dash h with the help of the formula. This formula is inversal. P dash h, P dash h equal to ph dot tb. And if you apply 2D tb, it will calculate the coordinate in 2D. And if you apply this tb 3 dimensional, then it will calculate the coordinate for 3D. options, and the method will remain same. In x direction, the unit is given, that is the value of tx, ty, tz will be given in question. So all these are about the translation. We will discuss rotation in next class, and after that we will discuss the concept of projection also. Then we will move to the other topics. Please switch on your camera so that I can take the. Please switch on your camera so that I can take picture. Okay, thank you. We will meet in next class.
Okay, yeah, good afternoon, everyone.
Good afternoon, ma.
Good
Yeah, I'm
afternoon.
Moni Sahai. I'm from Mignu Regional Center, Delhi 1. And I thought that today I will be interacting with you all. But because of two reasons, I think it would not be proper to discuss or interact first because the time I think is already over. It is going to be 6 p.m. now in India, and the office people who are managing this class will now have to leave. So that is the first reason. And the second reason is that the attendance I found is very less. In the WhatsApp group that we have, there are around 60 students, 57, if I, yeah, 57 participants are there. But in the class, I found that there were hardly, 7 to 8 of you. So I could not understand what is the reason. So if like briefly you can say like what are the reasons so that we can at least discuss in the WhatsApp group also. And because this is your fourth semester and you will be completing your MCAOL program, if you do it correctly and if you do all the academic requirements that are there, then you will be completing the program successfully. So this really worries me that why students, all of you are not participating. What could be the reasons? Anyone from you would like to briefly talk about it? Yes. Yes. Yeah. Yeah. Okay. So as the yeah. Okay. So I would like to share one thing with you all here is that I had if you remember I had obtained a feedback from you all a few months back through the Google form. Okay.
Yes.
And around 50 MCAOL students gave their feedback through that form, and around 50% of them were working. So, in the open and distance learning system, generally what happens is not only in India or with IGNU, but even the other open and distance learning systems, generally what happens is that, attendance is optional because the open and distance learning system assumes that most of you must be either working or must be engrossed or engaged with household works if they are females or anything. So we assume that learning is a part time activity for you. It is not a full time activity, so that is why attendance is not made mandatory. However, as far as practicals are concerned, In practical classes, the attendance is mandatory. 75% attendance is required. And moreover, attendance is also required because if you don't understand the concepts in the practicals, then definitely it will be going to be difficult for you. So attendance in practical classes are mandatory. I understand that this is a sponsored program. So many of you might be having your priorities here and there, and because you got a chance, so you have taken admission in MCOL. I'm talking about, some of them, maybe that could be one of the reasons why they are not interested to complete it. But I think, as it is, if you are in the IT field or if you plan to make a career in the IT field, then definitely this degree is going to help you, you know
Yes,
so,
ma'am.
if you all can, complete the program as far as assignments are concerned, because that is what I look after at the regional center. So, some assignments of the third semester also have gone for evaluation. So, maybe in the next, 15 to 20 days, those assignment marks will also be reflected in your grade card status. So, assignment marks will not be an issue. And secondly, the term and exam also will not be an issue, the results, because almost every week the IGNU headquarters is taking feedback on how the classes are progressing, and what is the completion rate of students, how are they being facilitated. So these are the points of discussion for eVidya Bharati students in IGNU. So even like if there is some delay in response to your queries or something like that, please don't be worried. The university is fully concerned about your academic interests, and we are trying our best at every level to provide you the best support services. Though, in case if you feel that there is any need or you need some instant assistant or information, then I am always there in the WhatsApp group. You can always contact me, and I will try to help you out as much as possible on behalf of IGNU. And yes, yes, somebody has raised. I'm actually attending this call through my mobile, so I cannot see the name here. Somebody has raised his hands. No,
He
I
has
cannot see your
muted
name.
himself, so he has to unmute himself and speak.
Can
Unmute
you
Greetings,
please
yourself.
be a
everyone.
bit?
My
Yes.
name is Charles Ifenso.
Yeah.
I think most of the problem, like me in person, I encounter is a communication issue. We had a very poor communication right from
Yeah.
the initial, from the starting, when the admission
Uh-huh.
was offered. The information was not passed to some of us on time. We got to know very late. And
Okay.
unlike today,
Mm-hmm.
yesterday I was on the old WhatsApp group. I couldn't know about the new WhatsApp group. I was not aware. I'm not informed about that. Is a letter
Yes, Mr.
when I chat
Miss.
up the old what on the other WhatsApp group. I was told either by you that there is a WhatsApp group for the MCA online program, which the link was sent to us. And throughout all the first semester, second semester, and third semester, uh, I was not aware. I came in, I was aware when third semester was almost off. So,
Okay,
got to
Mr.
know, pardon?
Yes, Mr. Charles, I would like to respond to you. Uh, I saw your message in the other group, and when I created that WhatsApp group, at the same time, I created this WhatsApp group also. And let me tell you the purpose of creating that WhatsApp group. That WhatsApp group was basically created for all the students of all the programs which IGNU RC Delhi 1 was handling, who had never accessed their LMS. So that data we got from the university headquarters, and we were asked to create a WhatsApp group of those students who had never logged into the LMS. That means your status was completely showing as inactive. So we formed that group, and that group is a common group where students of other programs have also joined. But later on, it was thought that, let us provide some program wise specific support. So that is why another group was created, which is this one for July 2022 batch of MCA students, Similarly, we have July 2023 batch of MCA students also. That WhatsApp group also exists. And there is another group for common programs of eVidya Bharati students. So there are 3 to 4 WhatsApp groups. And the mail ID through which is your registered mail ID with IGNU, we had used the same mail ID to send you the messages for joining the WhatsApp group, be it the group of inactive students or be it the group of July 2022 students. So, and second thing is that, email is the most reliable, connection, we can say the connect that we have for you all as of now. As far as phone numbers are concerned, we don't have this international, calling facility at the regional centers as of now. And we have been trying to even international messages, international SMS facility is also as of now not available, though the university is trying for it. And email is the most reliable source through which we can connect with you. So we try to create a WhatsApp group by sending you emails. If in case you have not attended, then also it is fine. If you are interested, you can just visit your LMS and you can see that all the classes from first semester up till the third semester are uploaded on the LMS, the recordings of all the classes. So, and plus, in addition to that, I have also posted a YouTube link where you can get to see the, recorded videos of which the faculty has recorded. The School of Computer and Information Sciences faculty in IGNU, they